going to do some exercises here momentarily. But yeah, so anyways, all of the abstraction layers. So what I'm going to have you guys do for just a minute is hook up the simple sweep program. And then while you're doing that, I'm going to get some of these timing signals shown on an oscilloscope and a logic analyzer so that in a couple of minutes we can come back and compare on that. What the sweep program is going to do is basically just move the servo back and forth 180 degrees. So if you go to the Arduino.cc tutorial sweep, I don't think I actually copied this one up to the GitHub just to modify it. It's just in the examples. So you can open up an Arduino environment and go to that as well. But what the weird, why am I not? And I just assumed that you were looking at what I was looking at, but you were not. So you actually lost all the amazement of my clicking on the right tab among all those tabs. But all we're going to do is hook up 3 wires to the board. There's no real circuit here. So we'll load the sweep program into the Arduino from the examples menu. So off of examples, that's under there we go. Under, oh, you can't see this either. This is going to drive me nuts. Somebody's already sweeping, so I've obviously talked too much. John, I think you were psychic when you came in a couple days ago and dutifully worked on this in advance so that you could jump ahead of me.
I was in that book that's on the shelf over there.
Yeah, cool. Well, actually, shall I put you on the spot to have you walk through the code to talk about why it's sweeping?
Okay. They're all well documented there.
It is. The examples are really quite well documented. So just to walk through the include on the servo, this is the servo library, and when you're building your own, you'll go in and add that by including the library if you're writing your stuff from scratch. And that's what gives you the abstraction layer of not having to talk to PWM directly. Underneath it's talking to PWM, and then PWM is talking to the servo. We're creating a variable to store the position. You don't actually need to initialize it to 0 there, but it's kind of good programming practice. We're attaching to the servo on pin 9, and then our loop is going from 0 to 180 in the positive direction in steps of 1 degree, writing it, delaying 15 milliseconds, and then from 180 to 0 in the negative direction, writing it and waiting 15 milliseconds. One thing in here is that 15 milliseconds is basically giving you enough time to get that one step. That if you're going to go from 0 to 100, you're going to have to give it more time than that 15 milliseconds, or you're going to get bogged up. And there's no real signal when we get to some of the later modules in here, particularly the MP3 player module. We're going to have a busy pin that actually tells us when it's done. Tells us when it's done executing a command. And that's real good because you don't have to do these standardized delay loops, which aren't going to necessarily be standardized all the time. Like with the length of a song on the MP3 player, you don't know if it's 30 seconds or 2 minutes. And so it has to have that busy pin to tell you when it's done. But we don't have a busy pin off the servo, and so we just have to make sure we wait long enough before it can accept the next command in there. So that actually is... let me see if I can actually show on the oscilloscope the timing signals. Should have grounds. Should have a pin 9. And I should be able to capture.
Can can I connect my computer to the network here?
You can. Would you like to plug a wire in the back, or would you like?
Just
Oh,
wire it.
then it should automatically connect. It should be BioBit on the wired network.
Where's the password?
It does. Oh, that's right. BioBit 2014, BioBit 2014, all lowercase. We're a high security organization. You have nothing on her? You'll see a lot better if you put a wing on it.
Didn't like that.
It didn't like that.
2015.
2015, I'm sorry. Yes,
Oh, okay.
yes, I was off by a year. It's 2016 now, isn't it?
Nope, not like that either. Oh, yes, I was built. Nothing like that either.
It doesn't. It's supposed to.
So try 16?
No, I know I didn't change it to 16.
Or back to 14, see if that works.
Try putting a capital B on it, but here, actually, let me instead go look at what I've got, because I've got that's where I'm connecting to. How do I look at this? I didn't think with the wire I needed to do that, though.
Oh, it's the final bit of the name has two capital B's. Possible if that's the.
Oh, I don't think so, but I wouldn't swear not. Sorry, no. No, it should just be BIO BIT 2015, all lowercase.
As we've seen before, you did it a certain way doesn't mean it wasn't right. So let's try it again.
And I honestly didn't think that the wired connection required any authentication at all. I thought you just plugged it in and it worked. Because I didn't actually remember plugging any authentication on any of the Raspberry Pis.
Well, the wire connection would be this blue one, right?
Yep, that's right. Can you make sure the other end's plugged in? Andy, you're sitting next to the switch. Can you see that the blue cable that goes to Dawn goes into a switch?
I have no idea why you would actually need a password for an internet connection anyway.
I don't either.
Unless
It
it's trying to
doesn't.
connect to some sort of share is the only way.
No, it really isn't. I don't think there should be any password required for the wired connection.
It's like, what, DHCP?
Yeah, exactly. Yeah, sure, try that. Anyways, I am actually distracted and failing on getting the Nano to show the timing signals on this.
I can test the password requirement if you want. I can pull out the next thing.
Oh, sure. Yeah, please do. Hey, Zach, do you want to go get a big motor out of the DC Motors thing? And I don't know that we need to do a whole lot more recording. And if you want to jump in here, you're welcome to. But otherwise, we can just let it kind of run. I'm looking for one of the big DC motors on the top shelf that says DC motors on the hackable shelf. Did you manage to have luck, Don?
Yes.
You did,
It
okay.
was help.
Oh, okay.
It got help.
And it needed a password or did not?
I don't think it did. I think I was trying to get him Wi-Fi.
Oh,
I
okay.
plugged an Ethernet cable into it.
Gotcha.
And so the two goes down.
Okay, perfect. That
Switch
makes
to
sense.
Ethernet.
And the Ethernet works without password here.
Yeah, fantastic.
Yeah.
Excellent. Okay.
So
And I will quit
we
looking
call
at
that, we call
that.
that a case of pep
Of what?
cack. Problem exists between keyboard and chair.
That's right. That's right.
Before I hit the wire.
I taken pieces down, but you still want in the,
Well, he had one of my brother and everything.
is this part of examples?
It is part of examples. Yeah, if you're you're just looking for the sweep, right?
No, I was looking for the board. You had a picture of the board up there with the wiring on it?
Oh, I did, although the wiring is almost inconsequential on this particular one. It is,
If you
I'll
look at
put it
this,
back up over here.
I want to, I like the.
Oh, this is a 4-wire.
There is a smaller one.
Sure. please.
Yeah, let's try a 2-wire. And this is actually a variant of a stepper motor. And I guess we could talk about stepper circuits, but I think I'd rather not at the moment. If there's a larger 2-wire, then that'd be good. I'll hold it up though. 4-wire generally means stepper motor rather than servo motor, which you can wire up using the stepper library, but we would actually, that's where the H-bridge comes in really handy to drive that as compared to a transistor circuit, since you'd actually need to get power beyond your pins for both pins on that.
Yeah. Yeah.
Are you gonna play around with the code, like circle, or?
I'm going to suggest that you do so, yes.
How do we go around the circle?
Well, you can't make it go around all the way in a circle, unless we actually get into taking the stepper motor, the servo motor apart. These servo motors are actually limited to half a turn, and so they go 180 degrees one side or the other, but they can't go all the way around. Now, if you take them apart, there's actually, and I'll put this in the notes from tonight, there's actually a tutorial.
I noticed when I put it at 280 and 280, it was like.
That's right, it really hates that in a serious way. Here we go. So Hack a Tower Pro Micro, which is what this is. There's an instructable that showed how you actually do that, but it's kind of a silly process. So this is him putting it back together after all of that. That's not the one I wanted to see, actually.
Back to this guy here, does he go all the way around?
Yes, this guy goes all the way around. All this DC motor is a DC that runs always in one direction with this off-tilted weight on it, so that it vibrates badly like an out-of-balance motor. And so if you want something that goes all the way around, you can just actually pull the weight off and use it as a DC motor. Yeah. Are you thinking for wheels or something? Is that?
No, I was just curious, is that, like, obviously this is only not going all the way around. I don't know why, I don't know.
Right, right.
Yeah.
So that's because it has that sensor to say, yeah, where it is in there, and so you're providing a positional signals, and it only has 180 degrees of range to go with that. This whole process on this Instructable is actually talking about how to take the thing apart and make it go all the way around, and you have to do a little bit of soldering on the thing, and and cut it off with a Dremel. There's a well, except there's a difference. The reason that this has a very high torque motor in it, so this little guy. Let's say that you're building a wheel on a rover, and you want to be able to crawl over rocks and stuff. If you get more than just a few milligrams of pressure against this, it's going to bog down and stop. And so a DC motor, unless you get a big honking DC motor, like Zach just brought in, is going to be very hard to get enough torque to actually be in a robotics application. Whereas this guy is a high torque but low speed motor. And so it would be able to, if you made that little hack in there to make it go all the way around, be able to be a wheel driver and crawl over rocks and things like that, or climb your rope, for instance. You might find that a modified servo is a much better rope climber than you would a DC motor.
EF3 actually has one that's continuing application and contracting.
Oh, okay, cool, yeah. So that's basically when you make this modification, there's a little collar and a little stop on the wheel, and you cut off the stop and you take out the collar, and then this thing can go all the way around. And it can't track absolute angle anymore, but it can track relative angle. Canadian fruits actually still track absolute.
I think it's sort of like, I just saw the videos that we got a little explanation, and it sounds like it sort of incorporates an encoder that just sort of tracks numbers.
Oh, okay, that makes sense. Yeah, no, if they have an encoder in there, I can see how they would do that.
I think I've got problems uploading the board again.
Do you? Oh. Can you see if you can assist her?
Yeah.
Thanks. Yeah. Yeah. Next week I cannot. I'm afraid I can't sit in out of the day. I've got pieces of mine that it's coming up next week.
So you have to reselect everything
Oh, I can-
No, but I just upload it first run instead of sketches. And then I just tried to upload this one.
Sandy.
I don't know what to call it.
They're slicker. I'm just going. Actually, got them all.
Cindy Beeman at Gmail. Do you want me to just put you two in the house?
Yeah.
MSP, tell us that.
Okay.
Great.
Okay.
I'm not going to write it or anything, but here we go.
Okay, thanks a lot.
Yeah, you bet.
Well done.
You had servos doing wonderful things.
I did. Was it a tree? This was invented by the farmer.
It may well be. I wouldn't want to bet no on that.
Sure.
Yeah,
I have a little robot
Are you
tape
gonna-
thing that tracks the health of the plant.
There you go.
Well, there's a contact.
Excellent. Yeah, there's nothing to this circuit, so that's a good thing. Indeed.
Yeah, try bringing LED strip. Yeah.
But these actually have positive and negative, or the mostly doesn't?
It matters direction. If you reverse the direction, it reverses. Absolutely, yeah. So I was actually going to suggest that you go play with and to get some of these.
So I put in a transistor in series with that.
Fun doing, and maybe get the next one.
From last week.
What's
Sorry, over there, it's just,
Yeah, I would use that.
What's it called?
Brush. Yeah, if it's brushless, you need an electronic speed control. Oh, we could talk about that, if you are doing something like a quadcopter or something that has a high power requirement and also a high control requirement, the electronic speed controller on a brushless motor lets it have a lot more longevity than would a brushless motor. And they also generate more torque.
This is brush.
It's got little physical carbon brushes touching the.
where do we find wires and stuff?
Some of them are hanging out in here, but
I see.
most of them probably drifted back over to the other side.
And those, I mean,
Why don't you start with those, and do we have strippers sitting in that pile? Nope. Hey, Ron, can you find some wire strippers in your car? Actually, hey, Mark, if you want, Don has this there right here, too. Yeah, figure out where they actually are, good. Awesome.
People just one the other way from switching. But I use that. But I think we just reverse the direction.
They do. Yeah, absolutely, you can, man, if you want to play with it, I've got one right there.
So is it like, does it work the same as just like a turning knob?
Pretty
Is
much.
there like a little chip in it that does something?
No, it's,
Oh, yeah?
sounds like this on the
I just want to see.
Yeah,
That's
though,
all I want.
it uses my ramp up, then it goes and does something else.
All right.
So, I missed something in their code, but when it winds them up, it certainly, winds them up.
Well, don't put it in invite.
Yeah, but then it goes into something else, you can tell when it's done by ramping up, it actually shuts down for 5 seconds.
Okay. No.
Then it reverses, but there's something else going on in here too. But yeah, you notice 0 heat in these things. Yeah, which is funny because they're thermal
I'm sure.
desires.
Yeah.
There's like 3 years.
Yeah.
Sinking heat in that thing, so.
Hey, do you want to come look at big DC motor circuits over here for a second?
Yeah.
Mike has his up and running.
We will have your big DC motor running.
My code is doing gross things, but we'll see.
Oh, now you're
We're
getting
getting
shield as well.
Yeah. So the motor direction is indicated by LEDs here, which are like so stupidly bright, you can even read them side to side. So it winds down, reverses direction. After 5 seconds, starts up again. Now there's another routine that's being run in here. I don't know what it's doing. It's one of the
It's
can
spinning.
ones. Oh, it's definitely spinning. Yeah, good luck stopping it.
Right. Yeah, we have pretty high power motor.
Although, you know, it does flag an error if you do make it stop.
Does it? Oh, no, it must be using the resistive feedback to,
Well, it has, yeah, there's a current sense on the inside and back.
yeah.
Where'd you get this from? Hospital.
So off of, here, let me just shut this up so we can actually talk. On, actually, we'll look at it here, too, so
So
see.
your motor is bigger than my motor.
Oh, we're not comparing.
Yeah, yours is the
So the-
Clearly, yes.
This is the kind of ripoff spark funds funds for mono board. So of course, there's no documentation on the Chinese websites, but the documentation does exist on
What are
Spark.
these two units here?
These little beige guys are terminal blocks. All they do is give you away to connect the wires.
Yeah, so a DC motor just has two connections, and it's the polarity, and when it's attached, it determines which way it spins. And so that's why the H bridge that's used here is convenient on a DC motor, that lets you electronically change that polarity. If you're using a circuit like I did for the LED lights like this, you could get it spinning forward just as easily as that, but then the reversing requires something to switch it.
And if you look at that, you can understand pretty quickly why I went and bought it in China for $10 instead of $70.
Yeah. Yeah.
But you know, like their design is just as terrible as the Chinese one. But there should be a sea of holes because there's no way to get heat with these guys except this, which are like plated copper holes from the top and bottom of the board. And yeah, there should be dozens of them. There's like 500 each part. Not with a motor like this. This is designed for automotive use for seat positioning motors. So like they're rated for 30 amp speed kind of thing.
Over time, I got the.
They will get warm, yeah. I haven't gotten warm with these, but I have bigger motors at home.
Incidentally, there's a box over on the hackable shelf that has everything from this size to a great big motors pulled out, a blender, and there are all sorts of big motors over there. So feel free to either get the same circuit that we talked about for the lights or getting one of those kind of things to come in and see if you blow them up. Got one blow up?
What if the Arduino board goes first?
No, don't do it directly to the Arduino. I want you to, if you're going to do it without a H bridge, to do it with transistors. Last week.
Right, I have a schematic. for it.
Yep. And so
Even for that one small side I have.
Huh?
So, same deal.
For the small one in the kit, you can actually run it directly up, and it doesn't draw so much current that you would blow anything up. But that's a big enough motor that you definitely need the current protection.
And this one is just a transfer.
It's just a single transistor, and that will only let you run it forward. You would need to have
Does it come
a.
from, like, this makes it easier?
I really don't what that may come from the printer. It's about the right size for the printer roller motor.
So I have a popcorn maker that went to.
Oh, that'll be nice.
Yeah.
He's like special design.
Or
Or a triac, and then you can draw on that's a whole separate conversation.
Trying to figure out which one of these is.
I do. They're sitting on the yellow shelf in the kitchen side.
Okay.
Did we ever collect anybody on our stream?
No.
We did.
0.
Oh, okay. Well, somebody might someday watch the recording or might not ever mind. What do people want to do? Do you want to play with motors for a few minutes and get your motor wired, or shall I roll directly into distance sensors? Because I do want to talk about distance sensors at some point tonight, but maybe we take. Should we take 15 minutes?
Get these all.
Yeah, cool. Okay. Sounds good. I'll try and get the logic analyzer set up to play with forward in that too. I do. I have not seen it yet, but it is sitting on the big white table in my lab. So go to my left hand right, and it's in a brown box on the table. And you can actually turn the tool head up and see if you do a good job.
On the Arduino board, is it ground, the ground.
Ground. Yeah. It's actually, if you, you already got it. Never mind. If you look at the back of an Arduino board, you can actually see the. Yeah, exactly. Yeah. These are a pretty bad job, just because they're hard to see.
Yeah, I got the concept.
This one's a lot easier. So you can actually see that this is what's called a back plane. all of the spots that go between the pins that aren't broken down into small vias and wires inside the board. And so that backplane is ground all over the place.
Oh, that whole,
That whole plate is exactly. Yeah. Because the way they make the boards is that they start covering copper board and then it is essentially that. I don't believe it did. I think you're going to have to go and, yeah, so on the other side, there are a whole bunch of these, and I think you'll actually be able to
Yeah, that's what I was gonna do.
fit them together to get three to fit in there. There's actually in the box on the table side of the yellow shelves, a box with 3 and 4 pin plugs, and you'll probably find enough threes to fit in there. What's that? Hey, you did a good job. Oh. Oh, behind. I was just hanging on the barrier between. So you've got what you've seen it.
Yeah.
You
You tell which
barrier.
transistor you use to control more.
I find some strength in filling that.
Looking for the pin.
Okay, that's.
There's probably a bar across the top.
Oh, this is not a transistor.
That's a pretty good job.
So this is a 9-volt regulator, so not that one. Okay. And as for that one, if you punch in that number, the number there is. I have here 16, yes, it's in an equal 6.
You know, what I would try, what I would try, and you may want to experiment with this with one of the computers that's in here, is one of these little Wi-Fi connectors from that we tried to use on the Pies. I would actually, though, go on the plug cable on that computer, plug this in and see if you actually.
How did you tell that Broncos was a multi-trade?
The part number. I work with this stuff all the time, so yeah, I just get used to it.
Okay, so things go 1, 2, 3, that way. The positive signal.
If I,
No. That's those, so. Big one is the control.
Oh,
83.
Drain always goes to positive.
Yeah. And 3 source is.
You can always tell because the diode has to be reverse biased or short of power supply, so you always got to have the positive end of the diode pointing towards positive computer system. And that would conduct a lot of power, so.
So you move the up here. So it's P2 or the tab. It's electric meter. So this is the signal. That's the ground. That's the positive. You're rolling over. Go on the positive. Yeah. Yeah, where it goes on the motor, then it goes on the board. Yeah.
oops, I guess I didn't amplify it deep. You get the 3D printer up to, get your 3D printer up to Victoria today?
No, not yet.
You did not, oh, you're gonna take that tomorrow morning, or Armand come pick it up? Oh, I think he's driving tomorrow, isn't he?
Yeah.
Yeah, okay, good. That makes life easier.
Did my start routine, then I did their I don't know what, then I did their braking routine, then I did their other routine again, then I finally went with slow.
Do I want to mess with that? Sure, I'll mess with that.
Spend time to fix it. See what does it. Bigger screen.
Oh, which one is it? Oh, 15 is the Leonardo. Okay. Cool. Okay. Close that. So it looks like I'm not going to be able to show this live, actually. Yeah, for some reason, with my different configuration here than I had at home, I'm no longer connecting properly. But what I was trying to show with this is you can make an Arduino, and I was having a hard time on the Uno, but using the Arduino Leonardo, you can make it act as a logic analyzer. So what yeah, it's failing again for some reason. So what the logic analyzer does is basically tells you digitally across the time slice what the signals that are coming off of one of these pins are doing. And so when I was describing the size of that slice, or the size of the positive signal expanding, well, no, positional, that if it's 1 millisecond out of 20, it's going to be swung over to 0. If it's 2 milliseconds, it's going to be swung over to 180. And if it's somewhere in between, it's going to be in the middle. And so this is an open source